This is Calculus AB 2016 AP exam question number 5. Okay, let's just read the full question. It says the inside of a funnel of height 10 inches has a circular cross section as shown in the figure above. At height h, the radius of the funnel is given by, there's the formula, and the height goes from 0 to 10. In other words, you can see that when down here, when the height is 0, okay, you put a height of 0 in here, the radius would be 320. It's very small, close to 0. And if you put a 10 in there, the height of 10, you get 100 plus 303 twentieths, which is close to 5. So the height when the height goes from 0 to 10, the radius basically goes from about 0 to 5. Okay? It says the units of the radius and the height are in inches. Okay. It's a good idea to read all parts of the question because a lot of times they're related and you can hopefully catch when they're connected, and you don't want to do the same material twice. Okay? So the first part says find the average value of the radius of the funnel. Okay, the next part says find the volume of the funnel. And the third part says funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h is 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inches per second. At this instant, what is the rate of change of the height of the liquid with respect to time? Okay, they look like they're 3 different unrelated questions, but we'll keep an eye on them, okay? I want to go over something, introduce something here, a theorem, because it's very important, so I'm going to do a little backtracking on this here, okay? If I want to find the area under this curve, and I'm using the function that they gave us for the radius here, okay, this is the equation of that function right here, the graph of it, and if I want to find the area under this here curve, the yellow region, there's a theorem that says if I could form a rectangle, okay, and I could just make the rectangle is the same base as the function, okay, and if I could just fool around with the height of the rectangle, it's not a big deal, I'm not going to get too excited about it. If this region here would fill in here, that means that the area of the rectangle inside this blue box would be equal to the area under the curve. That's a really great asset because I could estimate the area under curves very simply by just forming a rectangle over the region, okay? Just by moving like this here. And it looks like in this case here, it looks like the height would be about 2, close to it. I'm not going to make a big deal of it. And so the area of the rectangle would be 2 is the height. The base would be from 0 to 10, which is 10. So the area of the rectangle is 20. That means the area under the curve is about 20. Okay? That's a very good way to estimate things. All right? Now here's the theorem written out mathematically. Basically it says that if you remember this, area of a rectangle equals area under the curve. And area of the rectangle, we do it in general. We just say the base of the rectangle is, the 2 points are B and A. So it's B minus A times f of c, which would be the height of the curve where it hits the function, okay? And that's equal to the definite integral under the function from a to b. Okay, so that's very simple. Area of rectangle equals area under the curve. Now, if I was to divide both sides by b minus a, I get f of c is equal to 1 over b minus a, the definite integral from a to b of the function, okay? And we call this f of c f average. So f average basically is the average height. If I was to come along here and draw all these vertical lines along here, the average height of this entire region here would be this value here. It basically says it would be close to 2. I mean, just from a quick look at it. So that's what the average height means. Okay, so now let's see if we can go ahead and solve this problem here. So here we have this funnel here. So it says find the average radius of the funnel. Okay, so here's the general formula. Okay, it's generic. It's just some f average, but we want to apply it to the radius. So f average is equal to 1 over b minus a, the integral from a to b of f of x dx. So we want to do, instead of f, we want to do the radius average. Okay, and that goes from 0 to 10. So 1 over b minus a is 10 minus 0. The integral is going to go from 0 to 10. Okay, and here's the radius function. And when we go from 0 to 10, that's a slight changes in the height. Okay, so I can show you here. We can just go to move this radius to the height, and you can see these are all the radiuses going across here. And saying the radiuses, remember we said go from approximately 0 to 5. And the way it looked from a shape we did before, it looked like the average radius was going to be in here someplace about 2. Okay, so that's all we have to do now. So we just have to do this integral. Now this is a constant times a function, so we can take the constant out. So I have 1 over 200, and then I just have to integrate 3 plus h squared dh. So the integral of 3 is 3h with respect to h, and the integral of h squared with respect to h is h cubed over 3. You plug in 10 first, so you get 30. Plug in 10 here, you get 1,000 over 3. And then I plug in 0, and I plug in 0 here, I get 0, I get 0 here, so minus 0. Okay? And now you go ahead and you can clean this up. So this is really 90 thirds. So this is 1,090 thirds. So here it is here. And if I clean this up, I get 1,090 over 600 or 109 over 60. Now, I just approximated this on a calculator just to see how close we were. So this says the average radius was 1.817. And when we did it on the picture over here, we said it looked like it was close to 2. Well, that's 1.817 is right about there, so it's very close. Okay, so that's a good way to estimate, and you can see we got it correct. Okay. By the way, when I'm doing these kind of questions here, if you're stretched for time, I would think you could leave your answer in this form here. I have this red one here. When I plugged in the values into the definite integral, this is, from here on, this is the actual, technically it's the answer, it's just not simplified. Okay, and this is a calculus exam, and I don't think they're going to take off for arithmetic. So this is a correct answer. You just have to clean it up arithmetically, and I think you could leave it in this if you're stretched for time. If you're not, go ahead and do the work. Okay, here's the next part. This one says find the volume of the funnel. Okay, so let's just see. This is what the volume looks like. So we're going to sweep through here, and here's the volume. We're going to fill this funnel up. Okay, so you can think of this as it's a pre-rotated shape. Okay, and if you took any slice through here, okay, you would see that we would get a disk. Okay, or you can think of it as this being the function and rotating this function about this green line, the axis of symmetry here. Either way you think of it, if you did it by slices or rotation, each cross section is going to be a disk. Okay, and so what you want to do is to find the volume, you need to first find the volume of this disk. Now, if you notice, this disk sweeps all the way through, and the disk is going to be, we're going to take the area of that disk, and we're going to add up all these disks with the slight change in the height. So there's going to be small dh, and h is going to go from 0 to 10. Okay, so that's what we're going to do. So we're going to find so in order to find the area of the disk, we need the radius. So the radius of the disk is given to us right here by the function. So the radius is 1 over 20 times 3 plus h squared. The area of each disk anywhere along here would be pi times the radius squared, because the radius is changing as you move along according to h. Okay, and then the volume is going to be equal to the integral from 0 to 10 of area times dh. Now, if you notice here, you don't learn to look at units here. Area is going to be inches squared in this case. dh is going to be, change in height is going to be in inches, even though it's very small. It's an infinitesimally small, close to 0. Okay, so this is inches squared times inches would be inches cubed, which is volume. It's always good to check units. And if I get confused, I look at units. It usually helps me out a lot. Okay, so here I have my definite integral from 0 to 10. Area is going to be pi times the radius squared and then dh. And make sure you include dh's in these things because that's an important part of the integral. Okay, now this is the product of two terms. I'm squaring them so I can square this. It's 1 over 400, and since it's a constant times the function, I can take it out of the integral. So I can take the pi and the 1 over 400 out, so I get pi over 400. And then what I'm going to do, this is a binomial, and I got to square it. So if you don't know how to square it, you just write it on the side, 3 plus h squared times 3 plus h squared, and multiply it out. And you would get 3 squared or 9. Double this term, it's just 6h squared, and h squared squared is h to the 4th. Okay, now I have, so this was just cleaning up the algebra. Now I need to integrate. So if I integrate with respect to h, I get 9h, and this is going to be 6h cubed over 3, which becomes 2h cubed. And this is h to the 5th over 5. Now I plug in 10, so I get 90, plug in 10 here, I get 1,000 times 2, 2,000, plug in 10 here, I get 100,000 divided by 5. If I plug in 0, each term goes to 0. Okay? Now again, like I said, if you stretch for time, this technically is the answer. It's just not cleaned up arithmetically. Okay? But if you clean it up arithmetically, you would get this, or 2209 pi over 40. By the way, you do not approximate pi, you leave it in terms of pi. And this is in inches cubed. Okay? The last part of this question is a related rate problem. It says that the funnel contains a liquid draining out the bottom. The instant when the height of the liquid is height 3 inches, the radius of the surface of the liquid is decreasing at a rate. Okay, so when I say the radius is decreasing at a rate, that means the radius is changing with respect to time, which is dr dt. And it's at h equals 3. So they're giving us dr dt at h equals 3. And since it's decreasing at this rate, it's going to be minus 1/5. And if you notice the units, inches per second, you notice dr, radius is in inches, dt, time is in seconds. So the units work out nicely here, okay? And so it says at this instant, in other words, when the height is 3, they want to know what's the rate of change of height. Well, the rate of change of height would be dh dt. So we're looking for dh dt when the height is 3. Now, I feel the best way to solve these problems, whenever you're doing related rate problems, if you know what you're looking for, over here is what you're looking for. If you know what you're given, okay, then I see these two variables r and h. I need an equation relating these two variables. And that was given to us. Okay, so it's right here. So let me just show you visually, though, what's going on. This thing is moving, and as it goes down, basically, as the height changes, obviously the radius is changing, but the rate of change of height is changing as it's moving down. Okay, this is not exactly true according to this problem, but you can see it's just moving as it goes down. Okay, and what we want to know is what the rate of change is when the height is down here at 3, at that instant. Okay, so as it moves down, we want to know how fast is the height changing when the height is 3. Okay, so I'm sorry, let's go back to the formula then. So we have the radius formula is equal to, right here was given to us, 1 over 20 times 3 plus h squared. So we're differentiating with respect to t. So dr dt, okay, this is a constant times the function, so it's 1 over 20. The derivative of 3 is 0. The derivative of h squared is 2h dh dt. Be very careful. It's 2 times h to the first times the derivative of h with respect to t. Okay, if you always do it that way, you won't miss the chain rule method here, okay? And so now we want to know what the h dt is when h is 3, so we plug in dr dt at that time is minus 1/5. This is 1 over 20. We have 2. At that instant, the height is 3, and we're looking for this term right here. If you multiply by 20, you get divided by 5 is 4. You divide by 6, you get minus 4/6, or minus 2/3, and the units are inches per second. dh is in inches, dt is in time or seconds. Okay? Very important when you're doing AP questions. It's a good idea to look at the answers, see what they give you points for, and what they take off for, so you get an idea of how much each question is worth. So you see they gave us 3 points for each part. The first part, for the average radius, they gave you 1 point for the integral. Okay, there's the integral. Remember, and dh is part of that. You need to you need to put that in there. They give you 1 part for the antiderivative, or taking the integral, which is this right here. Okay, and then they gave you 1 point for the answer. And like I said, I would think they would give you full credit if you left this is your answer and just put the units inches. Okay, the next part says to find the volume. So if you notice, they took the pi out immediately, but it's pi times the radius of the disk squared, dh. So you got 1 point for the integral. Okay, now this is just cleaning up the integral so that we would be able to integrate it, so you don't really get anything for that. But if you don't clean it up, you won't be able to integrate it. So you get 1 point for the integral, or the antiderivative. Okay, and then you plug in 10 and you get 1 point for the answer. And just like I said before, this is the answer. Okay, it's just not as clean as maybe they'd like it, but I would think they'd have to give you full credit. Okay, and also put volume members in inches cubed. And the last part, very important, they gave us the function, but when we had to differentiate it, they gave you 2 points for using the chain rule. Okay, 2 points for that. It's very important. And then just plugging in the numbers, you got 1 point for the answer.